Oh man, how's that? My mic was muted. I'm a derp. That's the best way to start the video, right? Thanks, man, for chatting at me, because I would have let that go for the whole hour, like an idiot. So hopefully audio's back on. Hopefully the stream is actually working meaningful. Let me know if it works okay. Anyway, so to recap what I just said that you couldn't hear, over the past 2 days we made a super silly physics engine of sorts, a little physics demo thing. We have sticks, which are these guys, which I put down first. There's no differentiation now, which we should probably change. And then there's pistons, and pistons change their length by about 40% over time in a sine curve. And sticks try to stay the same height. So if I lock this guy in and turn on animation, you can see that piston here is working and kind of making stuff move around, which I think is pretty great. It's just kind of fun to play around with. So what I want to do through these live streams is actually make a way for us all to just play with this and add stuff to it. All the code is open source, so you can look at it. I think it'd be fun to just add stuff and make a little physics game out of it. And today I want to work on a couple things. The first thing I want to start working on is showing stress for different pieces. So let me turn this off, as a piece moves, let's do that, right? So as the box moves, this box generally is not going to want to move at all because it's pretty well locked in. But if I add a piston to this guy right there, then it really stretches that short piece. That short piece is stretched a lot compared to what it wants to be. It wants to be about that long right there. And then when the piston pulls in, it really stretches it a bit longer. So I want to show that stress on the stick so we can actually see how what this looks like, and potentially add in broken sticks later on, which I think would be cool. So let's do that. Super basic question: do you need to be registered as an Apple dev to make apps for iOS? You need to be registered to ship them to the App Store. You do not need to be registered to just play around in the simulator. If you want to run it on a device, on your iPad or on your iPhone, yes. If you want to run it just in the simulator, if you want to run this code in the simulator, no, you can just download Xcode and play with it. So let's take the render methods. Let's go to our loop, our what will be, I guess, our game loop. We set up a CA display link, which is going to run, I think that means it runs every 30 frames per second, which is fine for the simple stuff we're doing. And then in DrawRect here, we clear the screen, we update all the points to their new locations, we give sticks better constraints. So this constraint stuff here, pretty sure that's the guy, yeah. So this method here forces sticks to stay their same length. So as gravity pulls everything down, it's pulling all these points just down a little bit. This point and this point are set to be immovable, so they stay put. This point is not immovable, so it gets pulled down by gravity, maybe down here. And then that constraint pulls it back up, so that way this stick is always the same length, right? So then in this render sticks method, I want to actually, okay, it just tells the stick to render itself, which is good. So the stick renders itself, and it currently just renders itself with a blue line. What I would like to do is there's the upcg float. We'll call this the ideal length, and that's our current length, and then our current length is going to be something else, right? And these are not necessarily going to be the same thing. We want them to be, but they won't necessarily be the same thing. So let's just let's just log it for now and see what those values look like. Length diff. Let's do cur minus ideal and see how big that difference is. I have a feeling for most stuff it's not going to be very different. Yeah, you can see it's very, very small. I'll put that over there so we can see it. Right, the difference is very, very small, 1 to 2%. If we pick it up and move it, let's pick up the box and move it, and we're shaking it around. You can see this guy right here is changing quite a bit. Right. And that's measured in pixels. Let's make it measured in percent. Right. So what's the change in length when something is under stress? It's probably 0 most of the time. There's 0.1%. Wrong tool. So even if I shake it around, it's hard to even get it when I'm shaking pretty hard. It's hard to get these sticks anything more than maybe like 1%. What if we make a machine that's really gonna give somebody a bad day? Let's see how bad we can make it. Right here. Oops, I shouldn't have done that. Let's do another one right there, and this guy right here. And I think that'll stress. I think that'll stress the system out. Let's see what happens. Yeah, so now you can see this guy is getting it to like 6% different, right? 6% at what he wants to be. This guy, is this guy even more? Yeah, this guy's getting it to 14%, 15%. Okay, awesome. Let's make 10% red, right? So if let's do the percent difference is going to be these things. We probably don't need to log it anymore, actually. Well, we'll still log it. No, okay, it's just spamming. We don't care. So the percent difference, if that is more than 10, then we want it red. If it's less than 10, then we want it closer to blue. Right, so we got UI color blue and red, right? If it's 0, we want blue. If it's 0.10, we want red. Equals min of 0.1 and that. Does that make sense? So now we cap it at 1. And then we're going to multiply it by 10. So now this percent difference is between 0 and 1. So now we have our actual color, render color equals UI color, color with red. We want green is always 0. Blue is 1.0 times 1 minus the percent difference, and alpha is always 1. Right? Does that feel good? So it should be, that way if percent difference is 1, then we get all red, no green, and no blue. If it's 0, then this is going to be 1, so blue is going to be 1, this is going to be 0, and this is going to be 0. Right? So now we can go here to set stroke. And now I think we should get sticks rendered a slightly different color the more stress they are under, which would be pretty great. Let's try it out. So we get this, we get this, we get this. Let's do that. There we go. And then we make a piston right here. And then we are going to should see, hopefully we'll see the piston especially, and maybe this little guy. We should see them slowly. Yeah, you can see things turn red. That's awesome. pretty great. Let's we do more there? Yeah. Yeah, you can really see it with that one where that piston, those two pistons, all those legs are really freaking out compared to where they want to be. That's awesome. Cool. Let's commit that real quick. Physics, yeah, there we go. Sticks color with stress, which is pretty great. So if you wanna play around with it while we're doing this, that's where the repo is. So you can just clone that and start running it, start playing with it. What else do we think? The other thing I wanted to do. So we currently don't have very many things. Here's a stick. A stick is just a straight line. Oops, and a piston. And a piston changes length, right? So those are the two things that we have right now. I want to do another one that is that's almost the combination of the two, right? And then maybe like that. I don't know what that looks like. Let's see what that looks like. Yeah, they just go back and forth. Anyway, see that dot in the middle? I want to make a contraption, another option, and we'll call it maybe an engine, or we'll call it, I don't know what we'll call it. But where there's two endpoints, and then a point in the middle slides back and forth. I think that would be cool. So that way we got a couple different options to add movement into the system. I think that would be a really cool one. And then after that, I think if we have time, we can start playing around with wheels or circles, hopefully. I think that would be fun. Let's find out. I'm gonna make sure. I'm gonna look at the stream again. Are we doing any better at all? We are not doing any better at all. Man, I just don't know what to say. It's having a really bad time. I don't know. Hopefully this records okay. I'll be able to look at it afterwards and we'll see. But anyway, hopefully it's visible. I want to check it real quick, because if it's really dead, then we will then I'll restart the stream. If it's super dead. Audio is coming through okay, which sounds nice. Yeah, our frame rate's okay. What it looks like now, it's like Inception worthy on live coding. That's awesome. Okay, great. Let's start building an engine, because we have stress. Oh, let's make sticks break. That'll be easy. That'll be fun. Let's do. How are we going to do that? How should we do that? I think we should do. Yeah. So okay. So there's one thing that I haven't handled at all yet, honestly, and that is right now pieces never get deleted, and so this will be good, because if we make sticks break when they're under stress, then that'll be awesome, and that will help us fix a couple different things with our system. Because right now we have an update points, this array which holds all of our point objects, these little red dots everywhere. These points are never ever removed, I don't believe, or in very, very rare cases. Yeah, only when we clear the screen and when we build, when we're building new stuff. So when we break a stick, like if we broke this stick right here that's under a lot of stress, it needs to not delete those 2 points, right? But if I delete either of these hanging sticks, the bottom point should be deleted. We shouldn't keep that around in memory. So let's do that where we can remove points correctly. So update sticks here. Now I think what I want to do is I think we're going to call this tick, actually. Yep, because that's what I did for pistons. And pistons extend sticks. So now we will go, here's our render method, and take our log out. Tick. Now we're going to go to, that should update here. Into our tick method and update. Great. And now instead of S, we're going to have self dot-length, this guy, there we go. And then our piston is going to do the same thing, super tick. Yeah, let's do that actually. Okay, so now everything should be the same. Yeah, now everything should be the same. It should just be a little bit cleaner, which is good. So let's make sure we didn't break anything. Awesome. So far, looks pretty normal. Great. Okay, so now we can go into here and let's figure out where, I need to organize these a little bit better too. Let's figure out where pragma mark helper render. And let's take update, enforce, render sticks. Then we have a render points somewhere. Oh, maybe sticks also render their points. Isn't that what happens? Yep. Great. Awesome. So now in our update method here, after we tick the stick, let's save our stress level. Let's make the stress a property of the stick. Right, and then when we're calculating our stress, I want to move the tick method up above render. So things are consistent. Okay, so now here our stress is calculated down here. Instead, what I would like to do is take our ideal length, our percent difference, and our difference here. And this is going to be stress, and this is going to be stress. So stress is going to go from 0 to 1, right? And then this guy is going to be stress. All right, so stress starts out as 0, which is fine. As things move along, stress gets closer to 1. So now we're going to take this off so stress can be higher than 1 if we want to. No, that's fine. We'll stop it at 1. And then here we can do if the stress is greater than or equal to 1, then we want to break the stick, right? Does that feel good? And so to break the stick, we want to do what? We want to remove the stick. We're going to reset our index because we're iterating with an index. So after we remove it, we need to start at the very, very next stick. The other thing we want to do is clean up unused points. Remove s.p0 and s.p1 if needed, right? We're going to do that later. So let's just see if the stick actually disappears like it should once it gets super stressed out, and how that works in the system. Is that gonna? Yeah, okay. So we get our box here. We're gonna do a crossbar. We're gonna do a piston. Oh, you know what we're doing? Oh, okay. Okay. That's what happened. We are using tick to do a couple different things. Tick machines is what we want, not update sticks. So update sticks, we don't want to tick here. This is where we do the stress calculation. And tick machines, this is where we do the tick, right? It was actually ticking twice. We don't want that. Okay, so now it should be okay. Now it should actually, oh good heavens, what is going on there? That's awesome. Now I think the sticks are not ever ticking. Man, what have I done? What have I done? Tick. So this guy adjusts the points. So the point adjustment does need to happen. So actually what we need to do is we need to take this. There's a couple different methods. We need to call this one constrain. Actually, we're going to call this like just calculate stress. No, we'll call it constrain. That's fine. I don't want to overname things. And so then tick here is not going to do anything. Is a no op in the default stick case. Constrainment will happen here and we'll calculate stress correctly. So in update sticks, we want to constrain. We don't want to remove them yet. Here we want to call sticks, right? And that is going to happen here. Void call sticks. Awesome. To sticks, and then a stick is sticks object at index. Great. There. This is what we want. And so this way, there are actually 3 different steps. let's go look at those 3 different steps. The 3 different steps are this guy, which updates gravity and forces on the objects. There's this guy, which loops a couple times, which makes sure things don't get too out of hand, and make sure sticks stay their same length, if at all possible, et cetera, et cetera. And then this is going to remove the stressed objects. I think that's what we want to happen. That looks right to me. So now that box is acting correctly, which is good. There's this box, which is hopefully going to get stressed out. Let's look at that. It gets stressed out. It gets mostly red. Maybe it needs to get more red. What if we make this guy, make him immovable? Yeah, so you saw that piston just broke. In not a very exciting way, but that's fine. So let's make it more. And then that, and then that, maybe? Let's see what that does. Yeah, there we go. That looked nice. So that way it stretches. Oops, no. I can't catch it. The way things stretch. Hey, that new one's not breaking. I wonder why that is. Just tight things there. There, that one broke, that one broke. Yeah, that's it. I like that mechanic. Awesome, that's fun. Good. And that feels like it takes them enough. For the most part, they survive. But there's, but not necessarily. Oh, there we go. But it actually takes a while to get them pretty angry. I want to break an actual. Yeah, there we go. That one broke the side of it. Yeah, that's great. I like that. Half done, broken sticks. Right, and it's only half done because we still need to clean up. We still need to clean up unused points, right? And it doesn't. This might be okay, honestly, that we're not doing this. I want to check on the stream real quick and see if it. No, it's still bad. I don't know why it's still bad. I don't know what to do about that. Maybe my internet's just having a bad day today. Anyway, so it doesn't make sense to me that there would ever be a high stress object that is not connected to anything, right? Like if I create this piston, it's hanging here, and if it breaks, then this point should disappear, but it's never going to break, right? Why would it ever break? It doesn't make any sense why it should ever break. I guess a very edge case is if there are if two things break at the same time. That's pretty awesome. We just made it rotate like an engine. That's pretty great. Maybe if two sticks are set up in a triangle like that and they both break at the exact same time, then it would have a problem. Can we get it? Oh. I want this thing to attach to it. I'm not adept enough. There we go. Dink. Oh, come on. Why isn't it moving anymore? Oh, that's why. So that's is that what happened? Let me check. So my thought, it should have stayed moving. These should have stayed pistons, and they should have kept moving just like they were. But I think what happens when I set up the drag, bink. Yeah, there we go. I just broke it off. That's a lot of fun. Shoo. I think what happens when I set up the drag is I actually rebuild the sticks. Let's look at that. So the create stick, the move point gesture. So this, yeah, if there's a point to replace, I loop through all the sticks, yeah, and if there's a point to replace, then I replace it, right? So what I really want is can I do that? I could, but I'm still doing stick width, and I have piston width. So that's not entirely what we want either. So I think to fix that, let's do this. Let's make a method that is this sucks, but I think it's going to be okay, and it's going to let us just move on, which is, I think, the important part. I really just want to get velocity building this thing, so I don't want to worry too much about how clean things are. Create a stick that matches our type. There we go. Are those supposed to be CG points and I did it wrong? Maybe. I don't think they are, and that's why I use the yeah, they're supposed to be P0s and then points. So why are you angry? Oh, that's why. It's meaningless. There we go. Let's do that. Right? Great. So now we do that with sticks. Now we do it with pistons, and we'll be able to do it with anything else that we build. Great. So now in here, instead of doing that, we do stick, create stick with P0. There we go. Let's make sure that fixed the bug. So it should now, when we connect things, like let's make a stick here. Let's do the same thing we were doing. Make that immovable and that immovable. Let's make a piston here. Turn it on for a little bit. And then set one here, like that. So now it should go in a circle again, sorta. That is the ugliest circle I've ever seen. So now when we move it, it should, yeah, there's still pistons, which is good. That's fine. And what we also want to do is we also want to set the angle of that new piston to match our current one, right? So that way, yeah, because it's, yeah, it's fine. Excuse me. Actually, I think I can do that, and the compiler won't get mad at me, will it? Yeah, it will. Or it won't help anyway. So that way it doesn't lose the place in its cycle. So now I feel good about it, and I'm also not going to worry about. I'm actually not going to worry about this. I'm going to put a note here. I don't think P0 or P1 will ever be orphaned without a stick, because stress stick will always share points with something else, right? So I just need to remove the stick. I don't actually need to do anything else. Comments, and what else do we fix? We fixed right? Cool. Great. Cool. So what's next? I think what we should do next is make an engine item that I was talking about earlier. And Keith, the Bit 101 on Twitter, who did the original JavaScript version of this code that we ported to iOS, the thing that he did is he made an engine that is back and forth, and then it would have, between these 2 points on the line, we have a stick, we have a piston, and if I turn that on, the stick is always the same length no matter what. The piston changes length, which is fine. The other thing that he made that I think is useful is kind of the in-between of these two, or the marriage of those two, where it's a stick, it's always the same length, but there's a third point that falls apart that falls across in the middle, and just goes back and forth along that line. And so I want to go ahead and make one of those. Let's get our segmented control. Where did that go? So make stick. We also want a make piston, and we want we're going to call it a make engine. Maybe next time we'll work on a better UI for all this stuff, but I think this will be fine for now. All right, so the segmented control, now it's 0, 1, 2. The grab is number 3. We're going to do a new create, and we're going to do a create engine gesture. And that's if it's a 2. Let's put these in order. We're going to do a create engine gesture here. There we go. There, now it should fire this method whenever that item is selected. Let's go do that. And gesture, great. And now we're just going to make it create a piston right now. We're also going to clean up this gesture. Yeah, good job, Adam. And gesture, how about that? Okay, cool. So now it should do the exact same thing. It should build fine. It should show our thing fine. And it should, yeah, let's move over our segmented control also. Let's move it a little bit further away. So now it should let us choose any of these. An engine and a piston should do the exact same thing, I believe. So there's our piston. Here is, oops. There is our thing, and they are both doing the same thing. Great. So now let's create a new item. Engine extends stick. Excuse me, my throat's just having the worst day today. Yeah. Yep. So this guy is also going to have what we're going to call an angle. Its length is actually always going to be the same as a stick. Its tick is going to be different, and its create is going to be different. Right? So its length is going to be the same as a stick, so we don't care about that. This is going to be engine, engine, great. And then this guy is going to be just like that. Great. And then we also need the set. I should have taken that guy. Oops. Okay, cool. So now we have, yep, now it builds just fine, which is great. So now we have everything we need to create the an engine. An engine is interesting because you drag, like here, when we create a stick, we're dragging out, we have the first point, which is where we press down, we have the last point, right? We know both of those points. When we create an engine, it's actually going to create a third point. So we need to handle that. We're just going to call it P3 because I think sticks already have a P2 property. Yep, they do. So an engine, sorry, is going to have a P3 property. Let's synthesize P3. And then in our init method, we need to initialize P3 as well. So init with P0, P0, and P1, that's fine. And then here, we want P3 to be the average of these two things, P0.x plus P1.x divided by 2. And the same thing for the y. And that's going to put it right in the middle, right? Which means what is it going to let us be? I don't know. I'm not mathing very good right now. So here we have our length. We're using cosine for the length. So cosine starts at 1 and goes to 0 over pi over 2, right? So does that mean, what does my unit circle look like? When is cosine a half? Is it in pi over 4? Probably not. Probably not. That's fine. We're going to do angle. Set angle to pi over 4. And yeah, we're just going to initialize this with whatever we want. Because the angle here no, what I want actually is, yeah, I think that's okay. And what I want actually is in the, there's a tick, there's a constrain. It's in the constrain. That's where I want to do it. Right? Yeah. That's where I want to do it. So we go here and we just call, yeah, I had it right. I need to keep it at half. That's fine. And then in constrain, we want to we want to move P3 to where it wants to be, right? And so P3 is going to want to be a certain distance away from P0 and a certain distance away from P1. And that's how we're going to constrain it. So if the point is here, but it's getting a stress downward, right? Then we want it to be able to kind of stretch off of the line. That's okay. But we want it to be constrained back towards the line. And we can calculate stress off of that. That's fine. And that way we can actually, that'll be really interesting, because when an engine has stress, when a piston or a stick have stress, they break and they disappear. When an engine has stress on its point, we can have the point break off and just become independent of the engine. And so then the engine kind of devolves into a stick. Hope all that makes sense. I think that would be a cool mechanic. I think that would be interesting. So let's go to our idealized length and our idealized angle. So we want its ideal. We're going to call it ideal distance to P0. This is just for reference. We probably want to call super constrain as well, because the stick has, we want to constrain the P0 and P1 first. So the ideal distance to P0 is the length times, like, say, the sine of the angle, and the ideal distance to P1 is the cosine of the angle. Right? Does that feel good? I think that's right. And so then if our actual distance to P0 let's just work through it and figure out what our thing is here. Oh, we want this is P3 to P0, right? And then so our dx and our dxy to 0. So our dx and our dy to 0. And then our actual distance to P1. I feel like his code was a lot simpler than this. He hadn't put it out yet, though. Yeah, I think it's because he just forced P3 to always be on the line, and we want to be able to stretch and stress it off of the line. I think that's the difference. So it's just a mechanics of the thing. Okay, so now we have the ideal minus the actual, right? Divided by the ideal. I don't remember why he divides by 2 there. That doesn't make sense to me. Okay, yeah, okay. Yeah, that's what we want. We want that minus that, right? divided by distance. Why does he do... Oh, that's why he divides by 2. He divides by 2 because he's going half one way and half the other way. That's fine. Yep. Divided by our total distance that we traveled, right? So I don't actually need these guys anymore, I don't believe. Nope. So this is the percent that's different, and we're actually not going to divide by 2. Instead, we want to do I'm probably over analyzing it, but if we use the sine and the cosine here, so this percent, this is basically how far off we are from where we should be as a percent basis. And so what this does is this splits that percent using kind of sine and cosine to say which side we're going to prefer it to get closer to. And that is overcomplicating it. We're just going to do that because we don't care. So now our offset. Yep, and if it's not a number, great. So our offset is going to be here. Yeah. That's wrong. Maybe it's not. Let's just do it and see what happens. This is going to be P3. P3 is never immovable because that doesn't make sense. And then it's also going to get the offset 1. And then our stress we're going to let be handled by the stick because we're not going to worry about stress quite yet for how this guy works. But we are going to worry about render. Let's render this guy. P3.render, and then render everything else. Actually, we're going to render everything else and then render that on top. Okay, so what I think is going to happen, with any luck, is when we create an engine, it's going to create something that looks like a stick with a dot that moves back and forth in the middle. I hope. Let's find out. Let's find out. Let's turn it off. Let's go here, here, and here. Like that. Let's make an engine and see what happens. It freaks out. That's awesome. So it gets really stressed out. Why does it get stressed out, do you think? Oh, because it keeps moving P1. I don't want it to move P1. I want it to move P3. Sorry. P3 also did not look like it rendered at all, which is interesting. Oh, yeah, that's why. The reason why it's not getting rendered, because we're not building it. Let's create an engine instead of creating a piston. There we go. Engine. There we go. There. Now we're creating the correct thing. So now we should be able to, if we make a little box, dink, and we make the engine on the top of the box, it should have a dot in the middle. It does. What happens when we play the animation? Nothing happens. And that's because these offsets are probably exactly. Oh, the other thing, we're not actually moving it, I don't think. We're ticking the angle, so that's good. So the offset is 0, 0, 0, 0 because the actual distances are fine, which is great. That's what we want. But we're not actually moving the thing. I think what we want to do to move the thing, what should we do? I think we need to calculate the new ideal point, right? Which is the ideal x is going to be, I think we used cosine for P0. Is that what we did? Oh, we haven't used it anywhere because I took that part out. Cosine f of the angle times P0 to x plus P1 dot x minus P0 dot x. Isn't that right? Right? And then the ideal y is going to be that, right? So then what we want is we want to constrain it to these, not to the distance. I think I did that wrong. That's what I did wrong. That is exactly what I did wrong. That makes so much more sense. Makes a lot more sense. Yeah. Yeah, so if that's my ideal, and this is my point, my P3. So dx is P3 minus ideal, and ideal y, right, P3 dot y. So now this is my distance between where I am and where I want to be. So we can actually just do that. So then that difference is what's the stress to make that a percent? A percent of what? What's that percentage of? Is it a percentage of length? Would we divide by length? It doesn't seem like it makes too much sense. Maybe it does. I don't think that makes sense. Let's just see what we get, right? I want to see the number, and I think it'll make more sense when we can actually see it happen. There we go, and then we make an engine right here. I want to actually see what happens. The difference is 56 all of the time. Why is the engine not ticking? The engine should tick. Why would the engine not tick? Riddle me that. Oh, sticks can tick also, can't they? Yeah. Use, guys. There we go. Tick all the things. Okay, great. So now we create our box. And we create our engine between the two things. We turn it on. It starts ticking, which is great. Otherwise, nothing's happening. But now we see it actually oscillating a little bit. Yeah, which is good. That's what we want. So if it's that many pixels off, the other thing that we do when we create an engine, here we go. And we have created the engine here. So let's create it, because we need to add P3. We need to add that to points, so that way that third point gets updated with gravity and with everything else. Right. So now we should see, since we're not actually ever manually modifying that P3 point, we should see it just fall to the ground. Movable, on, yeah, and it just falls off of the engine, which is great. So that's what we want. So now what we want is we want to make it stick to the engine. We want it to stick to where it's supposed to be. Pause. Stop. So the distance is, what's the difference? How are we going to do this? Because the two things I'm thinking of, right, is there's right, and then I make a stick down here, oops, and then a piston, right? And so this piston is going to pull this dot as this dot moves back and forth, or I would like this dot to move back and forth, and I'd like this piston to also be pulling on it. So as it pulls on it, I want it to actually pull it off of the line a little bit as it gets more and more stressed out, but I also like it to try and go towards where it wants to go. Right? Does that make sense? So I think actually what it's going to be, so the length it's going to be basically be a length constraint here, and length is going to go from 0 to ideal. So ideal length, this is my current length, this is the percent difference. Yeah, I think actually this percent and this percent are the same, are very close to the same. This is like the before and this is the after. So before, if we did this, if we treated this as P3 and P0, and then we got our distance of what it should be on the distance and the difference in the percent and the offset. But there's a distance here along this line, so let me, home button do I have? No. iPad 2. So there's, what's throwing me off is that there's not just this distance we want to be the same, but we also want it to be along this line. So if it's the correct distance but it's pulled way down here, then there's an equal problem this way, right? I hope that makes sense. I don't actually want to draw and show that. What I would like to do is yeah, okay. I think I know what needs to happen. It's basically like this dot needs to be constrained twice, right? And twice is P0 and P3. Self P1 and P3, right? Except this isn't P3. This is actually the ideal P3. So we're going to do ideal P3. Right? So that's good. And so now we need to do s0.p1.x is equal to self.p3.x. So now we move it to its literal place in life. Then we constrain it. And then we do p3.x equal s0.p1.x. This is really what we wanted to be doing. And then we do it again. We do it on the other side. Except this is S1, not S. We do it between P1 and P3. And this can go away. There we go. And then this guy is movable. This guy is movable. We turn it on. and it flies all the hell around. That is really funny. What if we do that? All right, so part of it is that cosine goes from 1 to -1. So we want now it goes from 1 to 0. That is absolutely awful. What am I doing wrong? What am I doing wrong? It's amusing, I suppose. That's pretty great, even though it's like wildly incorrect. Oh, okay. That's one thing I did wrong. That should be better. So as I oh yeah, because it was that's funny. Should this be P0 minus P1? Did I do that completely backwards? I don't think so. I should have done this a long time ago, just to prove to myself that we're calculating the ideal correctly. Because otherwise none of this matters. And we're not. I think we were. Yeah, so now we are. So that's what it should be doing. But it should be... Okay, so that's interesting. So if I make an engine like that, let's just make it so it doesn't wobble. And then I make pistons between them. What does it do? See, that should... It's not too fair because the engine is putting the dot in the exact place it wants it to be, which is fine. But then the piston is pulling it off, and since the piston updates after the engine, the piston always wins that war, so to speak, and it always gets to pull the thing off. Let's do it again. Let's not mess up the, man, every time I mess up, I think that pan gesture has a really bad day. This guy, and then this guy to here, and then this guy to here. That guy's movable, that guy's movable, that guy's movable. I turn it on. It's actually pretty good. Because this point here on the top left and this left-hand point should be sliding evenly up and down that left-hand side. And since the piston is updating after the engine, it doesn't get to. So if we do the exact same thing here, if we make the piston engine first, and then make the actual engine second, and then move this and snap it in. Are they not going to snap? Is it not... It's adding P3 to the thing. It should let it snap. It'll snap up here. Yeah. This guy should have snapped. If I make an engine, it's got a really bad day. Why doesn't the why didn't it let me move it to snap it on? Why not? It should. Move point. When it ends, the point to replace should be a thing. Point to replace is nil. Why can't it find a why can't it find a thing? There's 4 points that it knows about. 1, 2, 3, 4, 5 points on screen, so it's missing a point. Why is it missing a point? Why is it missing a point? I never set P3 to something else, do I? No. So when I make an engine, there should be 2 points. There are now 3 points. Oh, that's why. Because it is... No, it's not. Yeah, I think that's why. So if I make a stick and then if I move it, it tries to remove it's going to remove the yeah, so this needs to not be create stick with P0. That was the wrong way to solve that problem. This needs to be replace P0 with P, right? This is going to be new P0. This needs to be just replace point P with point, right? Yeah, so if that's what we want. And that way the engine can update its own P3 as it needs to. It really should not be called P3, it should be called P2. All right, replace point with point, and this is a void call. There we go, and now I do stick. Point to replace. With the grabbed point. Yeah. That's what we want. And now in the engine, we want to take this guy and extend it so that way he can replace P3. Which is a terrible name. So we will rename it to be P2. This is ideal P2. There we go. This is what we want, because now what's the matter with you? Yeah, that's fine. I don't care. Get out of my life. So now when we drop a point onto an engine, yep, it adds P2, which is great. So now we have 3 points. Movable, oops, sorry, movable and movable. So I turn it on, point goes back and forth, great. Make a piston, and if I move the piston, it should snap to it. Yep, point to replace. Yep, pink. And it snapped to it, which is great. So now if I turn it on, it's still going back and forth with the piston attached. And let's make a stick, which is going to give everybody a really bad day. The stick broke. Great. That's awesome. So let's do added engines. Yeah, I know I could get it. 18th time is a charm. Okay, so now let's make a box and figure out, good heavens, that gesture is awful. There we go. Let's make a box. Let's make one of those. Let's put an engine on it, like that. Let's put a piston on it, like that, which is going to have a really bad day. Let's make the top corners immovable. Yeah. That was awesome. You saw how it pulled the it pulled the point off of the engine a little bit, which I think is great. I think that's what we were going for there. So the other thing that I think would be potentially interesting is like so let's turn this off. Let's put a stick. Oops. Let's turn it on just for a minute. Put a stick right here. Let's add, like, if we add a bunch of pistons here to really pull that thing, how far off of the line can we get it? You can probably get it pretty. Yeah, this guy, the stick breaks a lot easier than the other ones. Let's reinforce that. Yeah. I was having a really crazy time. Interesting. Interesting. Hello, Zephyr and Domadrone. Anyway, I actually feel pretty good about that. We did a couple different things. We did, what did we do? We did stress on sticks and on stuff. So if we make a piston right here, it's going to stress these items. And we can see that with the red stick. Come here. Oh, I got it. Yes. This is truly silly. Yeah, you can see it. You can see it get red when it's having a bad time. And purple, yeah. So that's good. So things get red and purple when they're under stress and they break, which I think is fun. That machine looks silly, which is even more fun. I love that. I love it. Should probably have like maybe next time we'll make it so we can have a variable amount of stress, so things can either be super resilient and only break under tremendous stress, or they can be super fragile, and even the smallest amount of stress will break the item. Maybe we'll do animations, so that way when a stick breaks, it flies apart into different pieces and flies across the screen. Or maybe we'll do wheels. I think wheels would be cool, or gears would be really cool. I think gears would be fun. I think that would be lots of fun. But anyway, I think that's it for now. I'm going to get back to work. So all the code, let me make sure the code's up. You can get the code. Yeah, we're up to date. Yeah, so you can get the code right there on screen. I think it's in the description as well. So you can check it out, download it, and play with it, and just run in the simulator on your iPad or phone or whatever. But yeah, it's just a cool little like machine contraption maker that is pretty fun. And I think we can do some cool stuff with it and make really neat machines. But anyways, thanks guys for coming out. I think I'm going to call it. Subscribe or follow or both, or find me on Twitter at Adam Wolf if you want to find out the next time I stream. Hopefully tomorrow, but we'll see. I'm going to try to do this a little bit more regularly than I have in the past. But yeah, thanks for coming out and building this ridiculousness with me. I think it's kind of fun. Cool. I'll see you guys next time. Bye.